Hey everyone, so this is the 2013 AP Free Response question number 4. So we're given this graph of f prime. We're told that f is a twice differentiable function with this given f graph of f prime. F prime has some horizontal tangents that they gave us. They gave us the area under the curve in a couple of different spots, which is nice. The function f is defined for all real numbers and satisfies f of 8 equals 4. So that's going to be important as we look at some of these problems. So part A says find all values of x on the open interval for which the function f has a local minimum. We know to have a local minimum, we need f prime to change from negative to positive, right? If we think about a minimum, it looks like this. So we're going from negative to positive. So if we take a look at our graph, the only place that f prime changes from negative to positive is right here at x equals 6, which means that is the only place that f could have a local minimum. So f has a local minimum at x equals 6 because f prime changes from negative to positive. At x equals 6. Sorry, I don't know what happened with my handwriting there for a second. My bad. Okay. For this question, this was just worth 1 point. All right. So it was, oops, I didn't want a line here. This is what I wanted. There we go. This was 1 point. It was just a point for actually getting x equals 6 and giving an explanation. So this one was kind of an all or nothing. Part B says determine the absolute minimum on the closed interval from 0 to 8. Well, in Part A, we found the location of the only local minimum. So now the only difference between local and absolute is we have to analyze the endpoints also, because we could have the absolute minimum at one of the endpoints. So we're going to go ahead and make a chart first, a table of x and f of x values. And we know we're going to do 0, 6, and 8. 0 and 8 are the endpoints, and 6 is the only location of a local minimum. Now, when we're given a graph of f prime, the only way to figure out values on f of x is to use whatever initial we were given plus the integral of f prime. So we were given our initial condition is f of 8 equals 4. So we can actually go ahead and do that right away. F of 8 is 4. So our initial value is always going to be this f of 8, and our integral has to start at x equals 8 and go to whatever x value it is that we're trying to actually analyze and evaluate. Okay, so let's go ahead and do 0. So our initial is f of 8 plus the integral from 8 to 0 of f prime. And I'm going to go ahead and kind of jump over here for a second. So f of 8 we know is equal to 4. The integral from 8 to 0, well, that's backwards. So I'm going to go ahead and make it negative. And now we just need to look at the area from 0 to 8. Well, the area from 0 to 8 just means add them all up. So we've got 2 plus 6 is 8 minus 3, which is 5, and then plus 7, which is going to be 12. So the area between 0 and 8 is 12. Since we're going 8 to 0, we're going to do subtraction, and it's going to be minus 12. So we get negative 8 for x equals 0. Then we're going to do the same thing for x equals 6. So we're going to do f of 8 plus the integral from 8 to 6 of f prime. So we get 4, and again, that integral is backwards. 8 to 6 really means I'm going to make it subtraction and just look between 6 and 8. So the area between 6 and 8 is just this value right here, this 7. So 4 minus 7 is going to give me negative 3. All right, so if we look, we can see that the values we've got are 0 is negative 8, 6 is negative 3, and 8 is 4. So if we're looking for the absolute minimum, we know that that's going to be negative 8. So the absolute minimum of f of x is negative 8, and this happens at x equals 0. Now, you don't have to say where it occurs. I just always find it useful to specify it. In terms of points for part B here, this was worth 3 points. All right, so it was a point for did you consider x equals 0 and 6? So did you look at the correct values? It was 1 point for finding the right answer, so negative 8. And then it's 1 point for what they're calling a justification, but really your justification here is really just if it, that's not spelled right at all. It's because I'm trying to talk at the same time. Your justification here is really just the work that you're showing. So having this work shown is the justification for this problem. All right, moving on to part C. Now we're looking for where the graph is concave down and increasing. Well, we know for a graph to be concave down, we're going to be looking at the second derivative. So f double prime is less than 0. We're going to be looking for it to be negative. And then we're going to be looking for where f is increasing, which means we want f prime to be greater than or equal to 0. So when we take a look here, we are given the graph of f prime, which means we don't know anything about f double prime. We're actually going to be looking at the slope of f prime. So we're looking for where is the slope of f prime negative, but f prime is actually positive. So if we look at our graph, we want it to be above the x-axis and have a decreasing, or be decreasing. So we're going to be looking here, here, and that's it, right? So again, we're looking for above the x-axis because we want f prime to be positive, and we want the slope of f prime to be negative. So it's those two intervals there. So we're going to go from 0 to 1. So f is concave down. And decreasing on the interval from 0 to 1, union with, what is this one, 3 to 4. Because f prime is positive and the slope of f prime is negative on these intervals. Okay, looking at points for this one was worth 2 points. So did you get the intervals? And did you provide an explanation? All right, lastly for part D, we're given this function g of x, and we're asked to find the slope of the tangent line at x equals 3. Slope of a tangent line means we're looking for g prime. So for this one, we're looking for g prime of 3. In order to figure that out, we have to first find g prime of x. So if we look at this function here, we can see we need some chain rule. So we're going to drop the 3 and make it f of x squared. Oops, I need another parenthesis there. And then times the chain rule, which means times f prime of x. So if we're going to do g prime of 3, that means we're going to do 3 times f of 3 squared times f prime of 3. So let's see, 3 times, well, f of 3 they gave us as negative 5 over 2 squared times f prime of 3. Well, we're given the graph of f prime, so if I could just figure out what 3 is, it's right here at 4. And then we're just going to go ahead and simplify that. So we'd have 3 times, what is that, 25 over 4 times 4. So we get g prime of 3 is equal to 75. And there's our answer for that one. This one was 3 points. It was 2 points actually for finding g prime of x because you had to apply that chain rule. And then it's 1 point for actually getting your answer. All right. Hopefully that all makes sense. If you have any questions, feel free to email me. Thanks.